Hi, and welcome to your Balancing Chemical Equations podcast. In this podcast, we are going to briefly go over the law of conservation of mass, and then we'll talk about some strategies for balancing chemical equations. So before we get into the nitty-gritty, let's talk about what a chemical equation is. A chemical equation, you can think of it as being like a recipe. If I put these two things together, I'm going to wind up with this product. So your reactants and your products are going to come together. It's going to be a series of formulas and symbols that are going to represent the chemical reaction that's going on. So for example, we have some chemicals here, plus those chemicals there, and this is what we hope to form as a result of our chemical equation, or a chemical reaction. We always write our reactants on the left side of the equation. So carbon monoxide and iron 3 oxide are going to be our reactants. Think of those as like your ingredients. It's what you mix together. Your products are going to be on your right-hand side. Think of these as being your new substances, or I like to think of them as the cake I'm going to bake. So iron and carbon dioxide are our products for this equation. When you see an arrow, that is going to separate your reactants from your products. So it kind of keeps things separate, and we're going to use that arrow to kind of draw that line in the sand in order to balance a little bit later on. Coefficients are a balanced number of atoms on both sides of the arrow. So these numbers that are in front of each of your atoms, and there's no number here. If there's no number, we assume that it's 1, or else we wouldn't even write that as existing. So these coefficients are used to balance. When it comes to balancing, those are the only numbers that you can change. You cannot change these subscripts, because those subscripts were determined based on the charges of the elements, or whatever ratio those two elements have to come together in a compound. So you cannot change those subscripts. The only thing you can change in order to balance are those coefficients, or the numbers that are in front of your elements. And this is going to follow your law of conservation of mass, where whatever you start with, you're going to have to end with. It's okay that you take those elements and you rearrange them into new compounds, but you can't just start with lead and wind up with gold. That doesn't happen, unfortunately. All right, so now that we've identified some of the parts of a chemical formula, let's go ahead and talk about balancing equations. So each individual compound has to be written correctly before you balance an equation. If you're really struggling to balance an equation, most likely you have not created a neutral compound. So your subscript are probably incorrect if you're really having trouble balancing. So that's something that you really need to master, that skill of how do I create a neutral ionic compound by looking at the charges and dropping those charges into the subscript before you can even approach balancing. Your coefficients, or again, those numbers that are in front, need to be in the lowest terms possible. That means that if you can divide every single coefficient by 2, then you need to do so. They're not in the lowest terms possible. They're reducible. We do need to watch out for diatomic elements. Diatomic elements are these elements that like to travel in twos. So anytime they're by themselves, you're going to have to put a 2 in the subscript. And let's go ahead and write those guys out. We're not going to deal with them a lot right now, but we want to make sure that we have a list. Bromine always goes in 2s. Iodine, 2s. Nitrogen, 2. So these are elements that will never stand by themselves. If they are alone in a chemical equation, you need to put a 2 after them. Chlorine, diatomic. Hydrogen, diatomic. Oxygen, diatomic. Fluorine, also diatomic. So the way that I remember this is I like to smush all the letters together, and I just say Brinkelhoff. That's a good way to remember it. Another way you can remember this is have no fear of ice cold beer. I don't know. You're just going to have to remember that chlorine is not just C, and that it's bromine, Br, instead of boron. Either way works for me. Just make sure that you memorize these guys, because they will trip you up. One last idea before we jump into our actual balancing is there are a bunch of symbols that are going to be used in a chemical formula. After each of your compounds, you're going to see symbols that will tell us what state that compound is in, or that element is in. So if you see an S, it means it's in the solid state. L is for liquid, G is for gas. The one that's a little tricky is AQ, and that stands for aqueous. That means whatever substance I have has been dissolved in water. If you see a delta symbol or a little triangle, that means that you have to apply heat in order for the reaction to happen. You may also see, and you'll put that above the arrow or below, and you may also see a catalyst that's required, and we'll talk more about that later as it comes up. You may also see reversible arrows, sometimes written the way Word allowed me to, and sometimes it's written like this, but what you notice is you have a double-headed arrow, meaning my reaction not only goes forward from reactants to products, but it also goes in the reverse direction, recreating the reactants, and that will depend more on equilibrium and Le Chatelier's principle, which we will get to later. All right, so I am going to assume that these practice problems have the compounds written correctly with the correct subscript to create neutral ionic compounds. So I'm going to start with just the balancing phase. So when you approach these problems, and these are kind of scattered funny, so I'm going to have to apologize, but I needed to have room below them to work. I like to separate and draw a line through that arrow that separates my reactants from my products because I know whatever I start with has to match whatever I end with. So I'm going to go element by element. And I'm going to make sure I have the same number of elements in the beginning as I do at the end because that's the law of conservation of mass. You can't have more or less than what you end up with. So here I see no number, no subscript. That means I have 1 sodium. Great. Going to the other side, I see a subscript which tells me that I have 2 sodiums. So I'm going to go back to the number that's in the lowest. So this sodium is the lowest, and I'm going to think what times 1 will give me 2. And that's the number that I'm going to put in the coefficient spot. So now instead of having 1 sodium, I now have 2. Those are equal to each other. Now I'm going to move on to sulfur. On this side, I see no subscript and no coefficient, so I know that I have 1 sulfur. On this side, that 2 only applied to sodium. There is no number right here. I don't assume that it's 0 because there has to be something there if we've written it. I'm going to assume that this subscript is 1. No, my pen's not working. All right, so I'm going to assume that this is 1. So on this side, I also have 1 sulfur. Well, those are already balanced, so I don't have to put anything into my coefficient. So in the end, it's 2 sodiums plus 1 sulfur gives me sodium sulfide. Moving on to the next problem, I'm going to again draw that line in the sand to separate my reactants from my products. And I'm going to start element by element. I have, according to my subscript, my coefficient, 1 potassium on this side, 1 potassium on this side. There is no number, so we assume it's 1. Those are balanced. Fabulous. Moving on. Oh dear. On this side, I see chlorine. Remember, chlorine is a diatomic element, and it's by itself, so you have to have a 2 in the subscript there. That's what that would look like. On this side, according to my subscript, I have 2 chlorines. Looking at the other side, I only have 1 chlorine. So again, I'm going to go to the side where it's in the least, and I'm going to think, what can I put in the coefficient side times 1 that will give me 2? Of course, the answer is 2. So now I have 2 chlorines. Those match, but oh my God, I've just changed the number of potassiums. Don't fret. We're going to be okay. So now instead of having 1 potassium, I now have 2. Well, crap, that is unbalanced. So I'm simply just going to go back to the reactant side. I'm going to think what times 1 would give me 2, and I can put a 2 in the coefficient spot. So now I have equal numbers of potassium and chlorine on the reactant side and the same number on the product side. Not a big deal. Let's move on to our next problem, or our last problem. Draw my line in the sand, and I would like to use purple. So starting with iron, I have 1 iron on this side. Okay, I have no coefficient, no subscript, so I assume there's at least 1. And on the product side, my subscript tells me that I have 2. So I'm going to go back to the side that's the least, and I'm going to think what times 1 will give me 2, which is 2. Now I have 2 irons. Those are equal. Moving on to oxygen. I have 3 oxygens on this side. And notice that I'm working oxygen backwards. That's a skill you're going to want to use later. You'll want to start on your product side and then go back, but we'll talk about it more when we get into more combustion problems. And here we have 2. Well, shoot, this was a lot easier when I was dealing with 1, and I could just multiply my coefficient by whatever number I needed in order to get the number I needed to balance it. So here, oxygen on this side is 3, and oxygen on this side is 2. So I have to think, what can I put in the coefficient that will multiply the subscript to get the same number? So I have to think, what is the first number 2 and 3 have in common? Okay, I can't multiply them each by 1, or I'm still going to have 2 and 3. I can't multiply them by 2, or I'll have 4 and 6. But if I multiplied this side by 3, I would have 6. And if I multiplied the other side by 2, I would also have 6. So the first number they had in common was 6. So I have to think, what can I multiply each of those by to get that number? Well, of course, this is going to change my number of irons to 4, and they're no longer balanced. My oxygens are equal. I have to go back and fix those irons. So again, here we have 2 irons. So my subscript is 1. So if I multiply that 1 by 4, and I'm sorry, I can't erase this or you're going to miss getting to see that earlier on. If I put a 4 here instead of that 2, I now have 4 irons on each side, and I now have 6 oxygens on each side, and we're now balanced.